So if you did not finish 3-2 last week or this weekend, you want to make sure you get that wrapped up tonight. Tomorrow in class is your next quiz. It's over 3-1, 3-2, and 3-3. It is open note, individual, no calculator, period. No calculator at all. Okay? So, all right. You'll be okay. You can do it. I have confidence in you. You can do it. Some of you need a little more confidence in yourself, I think. All right. Do you remember in Algebra 2 doing division, synthetic division or long division with polynomials? Okay, so this should be a completely just review section for you that we're doing today, which is good. Okay. Right. So what I want you to write down from this, our book uses some pretty specific terminology for all the pieces that make up a division problem. Okay, so there are 4 terms at the top you need to write down: dividend, divisor, quotient, and remainder. And for us, eventually each of these is going to be a polynomial, so they each have their own like polynomial notation, the name of the function. So f of x we call the dividend, and it is just the original polynomial. It's our problem that we're dividing something into. D of x is the divisor. The divisor is what you're dividing in. So those first 2 things make up our problem, what we are dividing into and what we are dividing into it. And then the last 2 parts, the quotient and remainder, make up our answer. So that's usually what we'll be asked for. What's the quotient? What's the remainder? Quotient is how many times the divisor goes into the dividend, and the remainder is what's left over. What I want you to write down then from the bottom, and I'll leave this up here for a minute, there's 2 versions of the division algorithm. The one at the bottom is the better of the 2 because it labels all of our pieces and puts them together, I think. And this is also how we're going to check our answers, is with that version of the division algorithm. Okay. All right, so I'll give you a few minutes. You want those 4 terms, and you want the division algorithm written down. Everybody got what they need? If they need more time. Okay. All right. Okay, so this first problem, you don't need to write down. This is just review of long division from like back in the day, like 3rd, 4th, 5th grade, whenever you learned this. Okay, just with numbers, no polynomials yet. All right, so let's say I wanted to divide 1965 by 7. And again, you don't have to write this down. This is just review of kind of the process we're going to use. Okay, so 1965 divided by 7. What's the first thing I do? Good. Okay, so how many times 7 goes into 1, but it doesn't? So then we add another digit. How many times it goes into 19? How many times does it go in? 2 times. And I'm going to put that above the 9. That's important. Placement's going to be important here. Okay, then what do I do? Okay, so 7 and 2 give me 14. Subtract that from 19, and that gives me 5. Then what? Bring down the 6 and the 5. Does 7 go into 5? No, 7 go into 56. Yes, how many times? 8. 7 times 8 is 56. Subtract it. 0, 5. Does 7 go into 0? No. Does 7 go into 5? No. My remainder is smaller than our divisor. Okay, once the remainder at the bottom is smaller, I'll just put R of X, is smaller than the divisor, you know that you can't divide it anymore. Does it make sense that 7 times 28 gives me 1,965 there? What's missing? This is why placement's important. It's 280. There's actually an extra 0 at the end of that one. Okay, so divisor is D of X. At the top, we have our quotient, Q of X, and what we're dividing in is our dividend, which is F of X. So that's what all those little like polynomial terms you guys just wrote down a second ago are. Now, if I want to check this, here's how we're going to do it. This is the division algorithm. It says that 7 times 280, okay, so the guy on the side times the guy on top, or the divisor times the quotient, plus the remainder will equal my original number. And this is one that you could just like type in your calculator. 7 times 280, add on 5, make sure it gets back to 1965. And again, you want to always make sure that the remainder is smaller than what you started with. Okay, does that look familiar? Any questions? The process here? Okay, so the steps are on here that we're about to use. We just really reviewed them with numbers. I put them on the slide in case you want to refer back to them in Polaris, but we're not going to spend time writing them down. Okay, so here's what your problems are going to look like. It's going to say, find the quotient and the remainder when we divide this polynomial by this other polynomial. Okay, so here we are dividing 3x cubed plus 4x squared plus x plus 7 by x squared plus 1. Okay, so I'm going to set up my division bar. It's important when you set up the division for long division and synthetic division in a little bit that if a term does not appear in your polynomial, if you're missing an exponent, you put a 0 there. That way, when we start bringing things down, everything's going to line up nicely. Now, in our polynomial, we have an x cubed, an x squared, we have an x to the first, and we have a constant. So all of our powers are accounted for. We don't need any zeros. So those are going to go underneath. Plus 4x squared plus x plus 7. Okay. And then I'm dividing in x squared plus 1. Now, what I'm dividing in doesn't have an x term, so I'm going to put a 0 there. X squared plus 0x plus 1. That's going to make sure that I don't forget anybody when I start multiplying and adding all these things together. Now, I think the one big difference that we do here versus when we just do this with numbers is it's hard to look at this and say, how many times does x squared plus 1 go into 3x cubed, whatever. Instead, we're trying to think about x squared plus 1 times what will give me what's underneath. And you don't even need the whole polynomial. If you just look at the first term on each of them, that's going to be enough. X squared times what will give me 3x cubed? 3x. And we're going to line it up. It goes above my x term. 3x. Okay. Now, what's on top? I multiply by everything on the side. So 3x is getting essentially distributed in to the guy on the side there. So 3x times x squared gives me 3x cubed. 3x times 0 is going to give me a 0x squared there. And then, or you can just put 0, or you can just leave it blank. And then 3x times 1 give me a 3x. Then we're going to subtract. This is where a lot of people will make a mistake here. We are subtracting the entire polynomial. So you need to either put it in parentheses to remind you that you're subtracting all the way down, or you can distribute that negative through and then combine like terms. Either way works for you is fine, okay? If you're doing this right, the first term should always cancel though. 3x cubed minus 3x cubed, those are gone. 4x squared minus 0x squared is still 4x squared. And then x minus 3x gives me a negative 2x. And then bring down that plus 7. And then we do it all over again. X squared times what will give me 4x squared? Positive 4. Multiply 4 by everything on the side. That gives me 4x squared, a 0x, and a positive 4. Subtract. 4x squared minus 4x squared, cancel. Negative 2x minus 0x, give me negative 2x. 7 minus 4 gives me a positive 3. Okay, now look what I have. Let's label everything. I've got my original polynomial, f of x, which was my dividend. I have what I divided in, d of x, the divisor. Okay. I have at the top q of x, which is my quotient. And at the bottom, I have r of x, which is the remainder. Okay. How do I know that that's the remainder? How do I know to stop? Because the degree of what I have here is larger than the degree of what I have here. This is a degree 2 polynomial, and this is a degree 1 polynomial. So we're not looking at like the numbers being bigger or smaller here. It's more the degree of what we have is smaller than what we're dividing in. So as soon as that got smaller, I knew to stop. Now, when you type in answers in Math Excel, you will just type in the quotient, 3x plus 4, and you will type in the remainder, negative 2x plus 3. In the past, or if you Google something, it may have you might see this, negative 2x plus 3 over x squared plus 1. Did you guys ever write your answer like that when you did the remainder in Algebra 2? Okay, our book does not do that, okay? All you do is list what the remainder is and what the quotient is. So if you are like looking up tutorials online, you might see that. Just know that what you see in the numerator really is the remainder, okay? All right, if you want to check your answer, and we're not going to do all the math here, but I'll show you how you can set it up. You're going to do what we did on the previous problem. You're going to take what's on the side and what's on the top and multiply them together. Now here, that's x squared plus 1 times 3x plus 4. So this would involve with polynomials a little foiling. Then you're going to add on your remainder, and that should equal what you started with, your dividend. That's a D at the end of dividend. I don't know why I wrote a T there. Dividend. There we go. Not dent. Okay, so you would FOIL it back out, you would add on your remainder, and then you should get right back where you started if you want to check it. Now, that's going to take a little bit of time, but this is something like on your quiz tomorrow. If you want to go back and check your work, you can. Okay. What questions do we have? Okay. Do you want to try one on your own? Maybe, if I help you set it up? See what we can do? Okay. All right, so this is a z to the 4th. Then I don't have a z to the 3rd, so I'm going to put plus 0z to the 3rd minus 2z squared. Then I don't have a z to the 1st, so plus 0z plus 1. Make sure all of my terms are accounted for. We are dividing in z squared minus 2z plus 1. Okay, work together if you want. See what you can do. I'll give you a few minutes. I will tell you you are doing this problem right if you get a remainder of 0. You can check yourself. Go ahead. All right. Here are all the steps. If you did not get this, check it line by line, because if you make a mistake in like the second step, the rest of it's wrong from there. Usually it's just like the basic algebra stuff, like a subtraction error, or didn't bring a sign down, or multiplied something by something else that you shouldn't have. Little stuff with these. What questions do we have? Yeah?
Can you explain how you got the first one?
How I got this one here?
Yeah.
Yep, okay. So z squared times what gives me z to the fourth. So it's got to be a z squared. Then I multiplied z squared by each of these on the side. So z squared times z squared gives me z to the fourth. Z squared times negative 2z gives me negative 2z to the third. And z squared times 1 gives me z squared.
Okay, thank you.
Yep.
Why are you multiplying all by z squared?
Because that's what we decided goes into this polynomial to give me that z to the fourth. That's what I put up here. Whatever you put up here is what you are, that one term, that monomial, what you're going to multiply this polynomial by. Okay, and we get that because we look at the first terms and we decide this times what gives me this. Okay. Other questions? Do we want to try one more? Maybe? Yeah? Okay, real quick before I show you that next one. When we get a remainder of 0, this is going to be important for the lesson that's later this week. That means that we have factored the polynomial. Bless you. Something divides in evenly, we have found a factor, and that's what we're going to be doing when we do section 3.4 and 3.5. We're looking for factors. So what you divided in is a factor, z squared minus 2z plus 1. And what you have as your quotient at the top is also a factor, because if we look at that, what was it, division algorithm, it said that my quotient times my divisor, the thing on the side times the thing on top, plus the remainder, but the remainder is a 0, should equal the original polynomial. So when we do like synthetic division, this is the part you might remember from algebra 2, you want to get a 0 at the end, because if you get a 0 at the end, it's a solution or a factor or a root, things that we're looking for eventually trying to solve. Okay, so that's why we kind of need, this is like a skill section to be able to do what we're ultimately doing with polynomials next. Okay, so it is a factor if you get a remainder of 0. All right, we'll do one more of these. Do you want to do it together or do you want to do it on your own again? Own? Yeah? Okay, go ahead. I'll give you a few minutes. We'll try it. Let me put the answer up here. You can check it. Okay, and if you didn't get it, check it line by line. Probably just a little algebra mistake. We didn't get a remainder of 0 here, so we would say it's not a factor. Like that 0x cubed, because you're going to need that column when you start multiplying things together and adding and subtracting. What questions do we have? Yeah? Why did I stop at 3x squared? Because I multiplied this x squared times these 3 terms. There were only 3 terms. But I could put 0 and 0 there if I wanted to. Just give me anything. There were only 3 things to multiply by. Okay, and again, we stop at the end there because the degree of what we have at the bottom, degree 1, smaller than what we have inside.
It's not a factor because of this.
Because the remainder is not 0. Yep. If it's 0, it's a remainder, or if it's 0, it's a factor. If it's anything else, it's not a factor. Okay? Other questions on long division? This is the longer of the two, so synthetic will go real quick. Yep.
So you're going to be using multiple factors like x, just like x.
We won't have anything with other variables that we have to do long division with. No. Yeah. So yes and no. So it depends what you're dividing in. For the 3 problems that we just did, yes, you would have to do long division. And we'll talk about that in a second, actually. Well, let me just talk about it now. So if you're dividing in something that is bigger than a linear term, so it has a degree of 2 or higher, you must use long division. If we're dividing in something that's linear, a degree of 1, that's when you're allowed to use synthetic division. So all the ones we just did, we would have to do long division because what I'm dividing in is higher than a degree of 1. Now, synthetic division, and again, I put the steps on here for you, but if you need to refer back, but you really are not going to need to, okay? Synthetic division is used when we have a linear term that we're dividing in. So like x minus 3. X minus 3 has a degree of 1, so we can use synthetic division. All right, so here's how synthetic division works. We'll do a couple of them together. You are first going to put all your coefficients. There are no x's when you do synthetic division, no variables, just the numbers in front of the variables. If you're missing a term, you better put a 0. All right, so x to the third has a 2 in front of it. Negative 7x squared. I don't have an x term, so I need a 0, and then a positive 5 is my constant. Okay, so third power, second power, first power, 0 power. Then you're going to get a number in the box over to the side here. Here's how we get the number in the box. We're going to take our factor, our potential factor, our divisor, what we're dividing in, and we're going to set it equal to 0. If I set that equal to 0, I'm going to get x equals what as a solution? X equals 3. That's the number that goes in the box. Okay. Then that's how you set it up. That's it. The first term will always come down. It will never change. 2 stays as 2. Then we multiply. 2 times 3 gives me 6, and we're going to fill out a column at a time. The biggest difference between long division and synthetic division is we do not subtract, we add when we go down the columns. Negative 7 plus 6 gives me negative 1. And then we repeat it. Negative 1 times 3, negative 3, add down my column, negative 3. 3 times negative 3, negative 9, add down my column, negative 4. That last number is your remainder. Your remainder for these will always just be a constant, a single number, because it's a degree smaller than what we started with. It's got to be a degree smaller than a linear term, so it's got to be a degree of 0, which means there's no x. Okay. The other 3 terms, or however many you have in the front, represent your quotient, the other part of your answer. And you need to put the variable back into this part. The variable terms will always be 1 power less than what you started with because we divided in a degree of 1. So I started with an x to the third, which means this guy is a quadratic. It's going to start with an x squared. 2x squared minus 1x minus 3, and then again the remainder is negative 4. And I could look at this and say it is not a factor, which means x equals 3 is not a solution or a root or a 0 because I did not get 0 as a remainder. Okay? Good? Let's do one more together. 2x cubed plus x squared minus 18x minus 7, and we're dividing in x plus 4. All right, so coefficients. 2x to the third, 1x squared, negative 18x, negative 7. I'm not missing any terms. What number is going to go in the box for this one? If I set x plus 4 equal to 0, x equals negative 4. All right, bring the first term down. Doesn't change. 2 times negative 4. Negative 8. Plus 1 is negative 7. Times negative 4 is 28. Plus negative 18, 10. Times negative 4 is negative 40. Plus negative 7. Negative 47 is my remainder. So is x plus 4 a factor of my polynomial? It is not. What's my quotient? 2x squared again here, because it started out with a cubic, it's 1 power less, minus 7x plus 10. Again, these are fast, okay? Questions? All right. Go ahead and do that one real quick. You're going to need some zeros. All right. Did you get a remainder of 0 this time? Yep. Okay, and then your quotient starts out with x to the 4th because we had degree 5 polynomial. So we've just got some alternating signs there. Let's say it's factor. Questions on synthetic division? All right. Last slide I have for you is we usually use these two theorems like hand in hand. It's the remainder and the factor theorem. So the remainder theorem says if I have a polynomial that I want to divide by x minus a, and all I care about is the remainder, if I don't care about the quotient, if I just want to look at that remainder and decide is it a factor or not, because that remainder tells me a lot, instead of doing the whole division, we can just plug a into the function to get out the remainder, okay? And a is the number that you guys were putting in the box for synthetic division, okay? So it's after we set the factor equal to 0 and the number that goes in the box, saying if we take that and just plug it in, it will give us the remainder, okay? We don't have to do the whole division. So we use it for problems like this. 110th power, I'm dividing by x minus 1. Even with synthetic division, if I did the whole division, it would be 111 columns worth of information, and it would take a really long time, and I just want that final answer anyway. So instead, we use this, okay? So I take my x minus 1, I set it equal to 0, I get x equals 1. This theorem says if I plug 1 into the function, I will get the remainder, okay? So I need to do 1 to the 110th power minus 2 times 1 to the 57th plus 5. And even though they're big powers, we're taking 1 to that power. What's 1 to any power? Just 1. So I'm going to get 1 minus, I still have people evaluating this kind of thing wrong on tests and quizzes, guys. Make sure you do the power first and then multiply. It's just order of operations, exponents before multiplication. So 1 to the 57th gives me 1 times negative 2 is just negative 2 plus 5. So 1 minus 2 is negative 1 plus 5 is 4 is the remainder. The factor theorem takes that one step further. It just says, hey, is that a factor? If I get a remainder of 4, is it a factor? It is not, okay? It says only if I get out 0 is it actually a factor, which I didn't, so it's not, okay? So you might see problems, and we don't have to do this one at the bottom, where it says show that x plus 2 is not a factor. And there's actually 2 ways you can do that. You can do it with synthetic division, is a way to show that something is or is not a factor, or long division for that matter. You could use long division here, but that would be a longer way to do it. Or you could use the factor theorem. If you use the factor theorem, what number would you plug into the function? Negative 2. And in both of them here, we're showing that hopefully it's not equal to 0, because the instruction said show that it's not a factor. So you kind of know what to expect at the end of it. If it's showing that it is a factor, you should be getting 0. If it's showing that it's not a factor, it's not. And again, you have the choice there on how you want to do it, synthetic division or just plug the number in. Okay. If I were doing this like on my quiz tomorrow and I were you guys, I'd probably use synthetic division, because you won't have a calculator and the numbers might get kind of big when you start plugging in like negative 2 to the 4th power or something and then multiply that by something else. It's probably going to be easier with synthetic division just to divide it in and show that you don't get 0. Okay. All right, and that is it for our dividing lesson. Any questions? All right, so 3-2 is due tonight. Tomorrow is a quiz, open note, individual, no calculator over 3-1 to 3-3, so make sure you bring your notes. And then this Math Excel is due on Wednesday nights. You could tonight maybe just do a couple of each type that's on there just to make sure you're prepared for your quiz. That'd be a great way to study. Okay? All right. Cell phone lotto. Winner is 20. Circuit training this week is over dividing polynomials. So if this was relatively easy for you, it'd be a good week to do the circuit training.